My name is Lindsay Fox, and I'm a doctoral student here at the Stanford Graduate School of Education, and I'm excited to talk to you about some of the work that I've been doing about differential teacher effectiveness and whether we might be able to use multiple dimensions of value added in order to improve student-teacher assignments. And so when we think about teacher quality, we often think about the wide distribution that exists across teachers, and so we know there are some very good teachers and some not so good teachers. But what we've explored less in the literature is whether teachers are differentially effective within themselves. So within a teacher, are there differences across effectiveness in terms of the students that they teach, so different subgroups of students, and in terms of the subjects that they teach. And the reason that this is important to explore is it might have implications for structural changes in schooling. So for example, if we find that teachers are differentially effective in teaching math and in teaching reading, we might want to do some type of subject specialization, which we see more commonly in the middle school and the high school levels. The data in my study come from the Miami-Dade County Public Schools, and that's the fourth largest school district in the country, and so we've got a big sample of students and teachers. And what I do with the data is that I calculate value-added measures, which are measures that are intended to look at whether teachers are contributing to their student achievement above and beyond where we may expect them to have been. And so in order to look at the question of whether teachers are differentially effective across different subgroups, I create separate value-added measures for teachers based on those subgroups. So for example, I will create value-added measures for boys and then for girls. And what I can do once I have those value-added measures is I can correlate them. And what the correlation does is it just tells us the extent to which the same teachers who are good at teaching boys are also good at teaching girls. So I do this for various subgroups in the data as well as subjects, and I'm looking specifically at 4th and 5th grade teachers at the elementary school level. And this is mainly because the specialization piece across subjects is a little bit more relevant for this group. So once I calculate the value addeds, I can correlate them, as I mentioned earlier, and the results suggest that across different subgroups, the value added correlations are quite high. So they're above 0.9 in many cases, and even as high as 0.99 across the various subgroups that I have in my data, and across math and reading. So for boys and girls in both math and reading, the value-added correlations are very high. I also look at ability, free and reduced price lunch status, and various racial groups. So what that suggests to us is that because the correlation is so high, we can't really do any of the structural change that might increase student achievement gains by sorting students by subgroups. But when I do it by subject, I find that the correlation between the math and the reading value added within a teacher is around 0.7. So the correlation of 0.7 suggests that we might be able to leverage the differential teacher effects that we see in order to increase student achievement gains by resorting teachers into classrooms in the subjects in which they have a comparative advantage in teaching. And so that's what I do to explore the magnitude of this 0.7 correlation. What does that really mean? Well, we can actually do this simulation where we take the estimated value addeds and we swap teachers around into classrooms and let them specialize in the class in which they're most effective teaching. And so I do this simulation in a number of different ways. In the first way, we can use the value added that comes straight out of the model, and these are unstandardized value added measures, which mean there actually is sort of a difference between math and reading because we know in the math test there's much more wide variation in the test scores than there are in reading scores. And so ultimately what this ends up doing when you do the resorting is that you're putting better overall teachers in math. And so what we might expect or hypothesize to get from these simulations is we might hypothesize to get higher gains in math and lower gains and maybe potentially even negative gains in reading. And so in fact, when I do this simulation, I get gains of around 0.09 standard deviations in the math and negative 0.03 standard deviations in reading for an overall achievement gain of around 0.06 standard deviations. But you may be thinking that schools aren't really likely to be able to want to trade off negative gains in reading in order for these higher gains in math. And so an alternative way to do this simulation is to standardize the value-added measures and use those standardized measures in order to resort teachers. What happens when we use the standardized value-added measures is that we end up balancing math and reading gains out a little bit more because we're sort of putting them on the same scale and we're not privileging one over the other. And so this is going to be a little less optimal, but again, it will sort of balance out those scores so that we don't have these negative reading gains. And what we end up with is around a 0.03 standard deviation total average achievement gain. So those are the gains that we get from using the actual Miami-Dade County Public Schools data, but we can also actually derive what we think the gains might be when we do this type of resorting. So assuming that we can take every teacher who is better at math than at reading and assign them to a math classroom, and vice versa in reading, we can derive what the achievement gains may be. And in the case where we're using the standardized value-added measures, it turns out that those total achievement gains become a function of just the correlation between the math and the reading value-added scores for teachers. And that's what this picture behind me shows. What you can see is that the x-axis shows the correlation between the math and reading scores of teachers, and on the y-axis is the total achievement gains that we might expect to see. And what you can see is that if we have a really high correlation, so a correlation of 1 all the way over here, the gains are very, very low. If the correlation is 1, there is no room to get achievement gains through any of this resorting. However, as the correlation goes from 1 to something a little more modest to something that's perhaps even negative, you can see that the achievement gains become quite large. So when thinking about whether to implement a policy like this, we definitely want to know what the achievement gains might be, but we also want to balance that with perhaps other developmental considerations, such as whether we want this disruption to happen and whether it's more beneficial for students and teachers to be spending more time together when they're in those elementary school level grades. There's also the possibility that after we do this type of subject specialization, that teachers might actually become better and more effective in those subjects because they're able to dedicate more of their planning and their preparation time to just that subject. Finally, one nice thing about this policy is that it's a way to use our current labor force in order to sort of more efficiently make these student-teacher assignments. And so what it's doing is it's taking the teachers that we currently have, looking at some finer-grained measures to see whether they are differentially effective, and if so, we can place them in front of students and in classrooms and subjects in which they're most likely to succeed.